So please, a big hand of applause for Arnaud Lustra, who will introduce and explain ZOCP, a protocol for orchestrating things.
Yep. Thanks. All right. So, yeah. Okay, my name is Arnaud Loonstra. I'm from the Z25 Foundation, and I'm also doing research for University of Leiden. And I will talk about ZOCP. ZOCP is a protocol for application exchange with as little effort as possible. But before I will demonstrate what it does and how it works, I just want to provide a little bit of context in what we generally do, and by showing some videos. So this is an example of installations we built. This is a huge wall with jars in which we put lights, and it's all a digital installation. It's more an artistic installation than any practical application. But this is just an example of work we do. I have another small video in which we use the ZOCP protocol. And this is a very old military building in which we, on all the windows, we project historic pictures, and they all float around in the building. And this is all done with Raspberry Pis, which we control from Blender. I don't know if anybody knows Blender. It's a 3D. Oh, sorry. Yeah, I will try to speak a bit louder. So, but this is generally the kind of the work we do. So, I will just demonstrate what the protocol does. So instead of doing the whole presentation style sheets. So in here you can see a node editor. Like, I now have some nodes on the network, and I can just drag this around. And in this window I have the monitor application. This is a terminal application, so you can run it in an SSH session, so you don't need any displays. And you can see that there are nodes online. So then I can add extra nodes. I will just demonstrate some. So let's have an emitter. And this node just arrived here. And a node is an application. It can be a device, but it's always run inside an application. So you can have multiple nodes on a single machine like I have now. I have some colleagues here in the front. They are connected to this network as well. And I can connect certain parameters to others, like this. And through this system, data can be exchanged automatically. And I can remove it again. And I'll show you. Whoop. So I could have a keyboard node, so I can just type in here. This one shows here. And I can connect the output to this node. And then, well, I have to switch desktops now. So I have a type here. Last letter is H. You can see it here as well, right? Is this clear? here. So this is how you can build your whole network of devices. You can exchange all the capabilities, because these are the things we call capabilities, and they're exchanging their data through signals. So a signal is when this one changes, it signals this one, and he receives the signal, and that's how they exchange data. So I'll show you another example. I can also have nodes connect automatically. Nodes can do that themselves. I can do it through this node editor, but you can do it in code as well. So it's not like you have to do this through this editor all the time. You can do whatever. The only thing this one does is it just displays what is in the network, and it can modify it. Any node can modify any node. So now you can see that the subscribee is connected to the counter. So the two counters are connected, and I can do in my monitor, I can flip a switch like this one, you can see here. Oop. And I can enter it, and you will see it's running here. I don't know. And I have the same thing going on this machine. So everything is interconnected, exchanging values, whatever. So if I will do this, flip the same switch here, you can see it's changing and it stopped. So I hope this is clear about what this protocol can do. Then I can start telling about how it works, right? And do interrupt me if you have any questions. So, like I said in the beginning, this is the installations we showed. This is kind of the landscape we have when we are working with these kind of installations. We have all these type of tools like Pure Data. Does anybody know Pure Data? Right. Like Unity, well, it's a proprietary app, don't go there. Processing, Java framework, Blender of course. And we have all these devices, Arduinos, with corkpads, webcams, Wiimotes, Kinect. And every time we have to connect them in a different way. We have to write custom code, we have to import the library, whatever. And we were thinking, we have to do this all the time. It's very labor intensive. We want something more easy, because we don't want to write code. We want to build nice installations, good applications. We don't want to worry about the same bugs all the time. So that was one of the reasons we started thinking about a protocol which helps us. Another situation we were seeing a lot of times, we had many inputs, we had many outputs, but we had a single point of processing. And of course, it would be going worse once it increases. So this was also one of the motivations behind ZOCP. So we were more visioning a system like this. And this is also a bit how ZOCP works, because like I can control from a node other input, output nodes, whatever. And the challenging part is this one. You have to do some logic on the nodes. So you have to have a more smarter input and output systems. And this is what we're trying to build into ZOCP. So these were the requirements for ZOCP. So we want it to be very simple. Also mentally, yeah? Because if you're doing asynchronous stuff, it tends to get confusing very easy. So we want it to be as simple as possible. We want zero configuration. We don't want to work with manual parameters. knowing the IP address or the port number of every device or application. And we want it to run on TCP/IP, and of course we want open standards. And yeah, we deal with music, so it has to have some low latency, well, as lowest latency. But on the other hand, we also want reliability. And the last one, and this is where the terminal application comes around, is the unintrusive debugging and monitoring. We want to see what is going on, very simply. Yeah. So, how does it work? Well, I still have the thing open here, so I can just open. I'm going to do this by hand now. So I have to. This is all Python. I think you know that. Input. Oh, sorry. Yeah. Let's do it like this. Oh no. Yeah, that's good. This better? You can see this? It's a bit small, but that's only 800 by 600 screen, so. Oh. Anyway. So I have to import the ZOCP library, then I have to say node is ZOCP, and then I have to give it a name. I don't have to, but it's nice. Blah. And now I have a node, and I can register any data to it. So let's register. Register the string. Blah string. And we set it to blah. And then you have to specify what can you do with this string. Do you want to read it to it? Do you want to write to it? Do you want it to emit signals? Do you want it to receive signals? So I'm going for the read write, and I want to emit. Actually I want to receive. So sorry, string. Then I have to start it and run a loop, and it should be in here now, right? Yeah. So this one can receive strings, and it's initially set to blah. So again, if I do it like this, they are connected. I had this. Whoop, this one. The blah string is now K. Well, easy, right? So how does it work? We have 3 layers. The first one with the capability exchange. Well, you've seen the nodes. They have some set of parameters. We call that the capability exchange. And through this, like get, set, and mod commands, they are updated, changed. All the metadata is exchanged. Then we have the signals. Well, you've seen the signals as well. They are very simple IDs with the data. Couldn't be more simple. And on top of that, we also have streams because, well, we have ZOCP. It's running on 0MQ, and it's TCP. So dealing with low latency is not best. You'd rather have UDP then. So we were thinking like what ZOCP, there are many protocols that can do things way better than we could think of. So why not just use them? So that's where we have the streams interface. You can just tell a ZOCP node if it has a stream, like an RTP stream, video stream, and then you can make use of it. It will provide methods for connecting streams. and I will have a little demonstration of that as well. But first, like I said, it's built on top of 0MQ, and on top of that we have the Zaire framework with the ZRE protocol, and on top of that we have ZOCP. And ZRE, or Zaire, gives us the interconnected nodes. I'll just explain how it works quickly. Imagine two nodes, they broadcast, and that's how they discover each other, so they can do a handshake. Imagine a third node coming, it broadcasts, they can do a handshake, and now they're interconnected. And the nice thing about Zaire, we don't have to deal with this anymore. We have now a network of interconnected nodes, and we can whisper from one to the other, or we can shout, like that's group messaging. And that's what we use in ZOCP as well. So, yeah, before I'll continue, any questions so far?
Will this ever go to smaller microphones? Now it's fully based on Python. Will it be able to run on, for example, like Orchestra 0 or?
Yes, yeah, good question. Well, we are developing, we're focusing our development on Raspberry Pis. Yes, and we are doing this in Python currently because Python is just really great to do prototyping. We are still designing the protocol, and well, we'd rather not do that in C. But Zaire, the ZRE protocol, there's a C version already available. So, and we will definitely go to C because we need performance. So, yeah, we will go there.
Could you say a bit about the security model if you have one?
No.
Because you didn't put it on your requirements list.
No.
Or maybe it's because
Well,
you use cases.
yeah. I get this question more often, but we don't have a security model. We don't want to deal with that because security makes everything slow. And we don't, you know, we build an installation. You don't need security all the time. This is not the protocol if you want to do secure communication. This is protocol to make you build stuff, to prototype stuff. And there will probably be a time that we'll introduce encryption. But is that secure enough? I don't know. It's a different thought to the thinking for designing. Yeah.
Can you speak louder, please, because we can't hear that.
Yes. Yeah. Yeah. I cannot tell because I don't have any experience with the ROS operating system. So it could be, but I don't know. I just heard you say it has a server. It's server based, but this is not server based. This is a big difference, like XMPP or most other protocols. This is a standalone. It's a very lightweight system. You just open your node. You don't need any service. Nodes will find each other by themselves. You don't need any server that deals with stuff, because that's always trouble. Like we said, we want things to be simple. Why cannot nodes find themselves? They don't need any help. So.
I have a question. So did you port, or did you using the Python version of Zaire?
Well, we wrote the Pyre. It's the Python version of Zaire.
Okay.
Yeah. So we ported it to Python.
And it's interoperable with the C version, right?
Yeah.
I think so configuration. How are the node identifying on each other? I mean, what happens if for some reason the connection between the nodes gets interrupted and then they get back in the same network?
Well, they all have a unique UUID. So that's how they identify themselves. So as long as the UUID remains the same, it's okay.
The UUID right now gets generated on runtime by the.
Yeah. Yeah, you can set it yourself, but like I did in the examples, you just get a random UUID.
So I mean, if a node get removed for some reason and you didn't specify the UID, you're not going to have the same network as you used to have.
No, but we're not, in general, we don't use the UUID to reconnect nodes.
I see.
We use the capabilities. That's more identifying than the UUID. So, because we can have many nodes do the same thing. So we just say like this is a class of nodes. And if you're from this class, you can do this.
I see.
It's the same as like the monitor. This, well, it's off. This terminal application, it's our monitor, that just registers all the nodes. It just looks for nodes and then it's like, what can you do? Well, I want to know about it. And that's how it builds its own view. I had this one more demo where we can stream some stuff. I don't know if it's... So I had
We
some...
have about 5 minutes more.
Okay, well, if there's questions, we're gonna do the demo anyway. Yeah, like layer 3 can, yeah. What if nodes are not in the same network, like they're on some other network? Well, first of all, we use multicast for that. So your network has to support multicast then. And it's actually, for our road ahead, it's one of the research topics we're still into, discovering on one networks. There's in Zaire there's also a gossip model that they can gossip. But we're looking into more methods. More questions?
You showed that you can iteratively describe the data model of a node. Do you have any means to do that declaratively? So not that you call methods, okay, declare a string, declare a integer, whatever, but really in XML schema or something like this.
Well, I'm not sure why, because you just have a node and you describe it. And from, you can generate a description if you want, but I don't get what you're trying to accomplish then.
Yeah, you want to connect some systems, as you showed was a use case.
Yeah.
And sometimes the system will expose in some form a data model that you want to connect to some other node.
Yeah.
So right now you have to write the adaption layer by hand or generate it in some form.
Yeah.
Or maybe there is something to import.
Well, I'm not sure if you mean this, but you can the data model you describe, it can be anything. Like I've done now strings or integers and floats, but you just have to provide a signature of how the data looks, because data is always like, I have some integers or some characters or floats, but you have to provide a signature to it, and then you can do anything.
Besides data, can you also stuff like RPC?
Yeah, there is a call mechanism that you can call a method, but actually we haven't used it yet. So, yeah, what's the use then? But it is there. Yeah. We're now streaming a desktop, and I don't know if anybody. So this is a real-time stream, and I don't know. Is there anybody here with the Urbit monitor? Can you just modify it? So there's one guy here streaming a desktop to my computer now, and there's this other who can now modify what is going on. And this is oh well. Well, it's an OpenGL canvas, so it can just modify the 4 points of the plane. And you have to use the ASWD. Yeah, you've been out, eh? So it's just an example. This is happening through ZOCP.
Can you show what happens on your?
Oh, on my machine? What is this?
Yeah, I mean the node. So can you like the node's being edited, the monitor.
Yeah, but like, I don't know, this is the streaming node, but streams, we're still in designing the streams, so it's not in the node editor yet. So I can see it, show it, but
Okay, so we're finished.
yeah.
Arnaud, thank you very much.
Thank you.